Okay, we are ready to go. This is the first time I've ever streamed in my life. My heart's racing slightly. I guess, hang on. Gotta check sort of my camera position and that kind of thing. Yeah, happy with that. So yeah, we are, okay, the first 10 minutes or so I guess is going to be quite a lot of talking on my part, just because, well, I mean, I spent a bunch of time thinking to myself how I'm going to sort of design this, but I mean, didn't have to carry that over to the stream, I suppose, and try my best to make myself speak what I'm thinking rather than what always happens when you're sort of public speaking and you start sort of tripping over your words because you're nervous. That should be okay. So, why did I even bother to actually live stream this? I came up with 4 reasons. I don't know if I'll remember them all, but I mean, I'll give it a shot. So, first of all, I think it's nice to be able to sort of be involved in someone else's life as a kind of way of supporting them or whatever, just sort of sharing what you're doing with other people sort of appealed to me. Number 2, this should be pretty good practice for an interview, right? Public speaking interview technique, just trying to train myself over this project, which is going to take many hours probably, trying to train myself to just speak exactly what I'm thinking all the time pretty much, which is, you know, it's easy to sort of choke up and not do that, and I mean that's why I got pulled, isn't it? I applied to Cambridge to do maths. I applied to a different college, and that pure interview was five minutes of absolute silence because I got lost, but I was not brave enough to actually say that to anyone, so I just sat there. 5 minutes later I was like, I understand, let's continue, and that was it. I mean, no one had any idea that I actually did understand because I didn't say shit. So that's another thing to practice, and I thought this was quite a good way of doing it, even if I didn't actually stream it, even if I just recorded it. Number 3 is just having the schedule say, oh, I have to do this at this time of the day, it will get done. Despite the fact that, I mean, I've been putting off starting for a while because I wanted to get everything right, but yeah, whatever. At least this way, I mean, I have I think I said this evening, tomorrow morning, tomorrow evening, Monday morning, Monday evening. That's the 5 that I've planned so far, and it's kind of along the lines of, well, I hope I can get the first lab done, right? MapReduce. Hope I can get that done in those 5 sessions of 2 hours, 10 hours spent doing it. But more generally, just making sure you persevere through all that. It's 3 days, 1 lab. If I manage it, cool. If I don't, I'll have done a lot. I can just keep it going until 14th of June is when I want to stop doing this shit so I can watch the World Cup and go to Cambridge, watch Summer Games done quick and all this shit. See how it goes. Number 4, for bants, I mean, look at this shit. Everyone should give streaming a shot. It's kind of fun to just mess about with it. Spent quite a while setting things up. Rig that I'm using, this laptop, is a Dell XPS. Let me see if I can. Nah, it's not going to do anything, is it? If I put this in the camera, it might fuck it up a bit. Dell XPS 13. Ah shit, I tapped the microphone, sorry about that. That's going to be a bunch of ambient noise. Um, yeah, it's really weird because I have no idea that I am live. It just says that I'm live, but without being able to view it, I'm just hoping I'm live. If I actually turn it on to view it, the laptop's probably going to overheat. It's an alright laptop. I like that it's really light. I can put it on, I've put it on a book here to try to improve the thermals. So yeah, the heat management is pretty terrible on this laptop. I put like this box between the grill and open the window and everything, so hopefully it'll be okay. But yep, that is connected to a webcam, the fantastic Moto G3, famous webcam by Motorola. Yeah, check it out, DroidCam, yeah? An app that lets you turn an Android phone into a webcam. Pretty sweet. Well, it's slightly, it's at high risk of getting desynchronized. I can sort of, if you look at the editor, I can sort of do this to get the hand synced the right way, to see if it's vaguely synced up, and I spent a bit of time setting the audio delay as well, so I think it should be okay. It looks so much more engaging if when you speak your mouth moves the right way, like, yeah. Yep, that is connected by USB. Let me just take it on tour. I hope I don't break it or it gets desynchronized, but take a look at this shit. When I do this you can see the extreme screen tearing. Actually, it's not that bad, is it? It's a bit teary at the bottom. Yeah, so this is my camera stand. I made it out of Connects. I have this shit just lying around my room, and I made the guitar capo out of it once, but that was by a guide, and that was the only thing I ever made using it, so it didn't even occur to me until just now, look, stand made out of Connects. I can just put it in. It's a good stand. It'll support the weight of the camera. I can, move it up, down and then up like that. So it's move shit. It's a lot better than the chin cam on the original Dell XPS 13. It has an integrated camera, but it's fucking down here, at the bottom. If you can just see it where I'm pointing, ridiculous location for a fucking camera. But anyway, that's okay. Microphone, OG microphone from my Windows XP computer, plugged in manually, because if I used the inbuilt microphone, then if I did this, you'd get masses of noise coming out of it. But now, it doesn't even really affect the volume level that you can see on the screen, so there is that. Alright, and that is that. 8 minutes. Gonna try not to spend too long rambling about stuff not related to what we're gonna be doing, which is, there's always some fuck who has just turned on the engine and is leaving it idling over there. If I could throw fucking eggs, stones and shit. I'd still rather have the window open. Just the cooling is wonderful. The fan actually hasn't even turned on yet, which I'm surprised by. It makes me think I'm not actually streaming. If I go through 2 hours without actually streaming, that's going to be sad, but it should be okay. It says it's live, so. It would also be a good way to practice social anxiety, right? The sort of, the little, I should have set it to silent, the little things that are little tics that people have when they're doing public speaking. So for me particularly, I have a bit of shortness of breath, but I also have I'll randomly just start crying. But crying isn't even the right word, it's just tearing up sometimes when I'm speaking. So it'll be a good way to practice that. I can blow my nose on stream as well. Yeah, it will be fun doing this in the daytime as well. I'll get a lot of daylight, probably pull the drapes up all the way. You can see out the window if I just do this, right? Or if I take it on tour. I promise I'm not going to spend that much more time rambling about bullshit. I'll save it for when I'm actually supposed to be doing the work. Make sure I hold the phone. If I drop the phone, that would just be tragic. Yeah. Anyway, that's where I live. That ends the fucking Chav estate. People on like hardcore feminist forums will say like, oh, you shouldn't call them chavs. Chavs is derogatory. It comes from some like really cuntish word that means something really bad in some language I can't remember. But I mean, I reserve the right. You know, people who don't live on an estate are privileged in that sense that they don't have to put up with all the shit that neighbours cause, and so. But actually, it's okay. I mean, thanks to social cleansing, life has improved somewhat since I moved in. Yeah, fuck that. Okay, anyway, let's have a look. So, I also have this just to monitor CPU temperatures, just in case. I mean, this laptop will usually run at like 90 degrees. It's quite bad, but it's small, so. So, alright, why am I... One sec. Yeah, it's okay. So why am I bothering with distributed systems out of all the shit that I could be doing? Yeah, actually fucking smells of crude oil in here. Cunt badgers. So why am I doing distributed systems of all the courses? Well, I mean, what prompted me was the previous rejection. Yeah, soz, we're only hiring experienced distributed systems engineers, come back in like a few months or something. Twat didn't even say what he meant by a few months. When I asked him, nah, it's fine, I probably forgot to reply. But, yeah, it's a course that has obvious import, well, a topic, right, in CompSci that has obvious importance in modern software engineering, web development, because what it is how do I get software to run on loads of computers at the same time so I can handle massive scale. And when you have that kind of hive mind, like I really hate it when people use that word in social media, but it's actually applicable here, unlike your fucking, I don't know, people who use the word hive mind on Facebook, not happy about that. But yeah, it's about getting the hive mind of computers, servers and shit to, well, split the labor up so you have different computers doing different things, like serving the incoming connection requests. If you're Facebook, customers, consumers are going to be connecting to your website, so the front end of that. Then the databases that store all of the data, all of that juicy Facebook data, and so it's like, yeah, so you have that division of labor, and you also have like, I have like a massive amount of data, which is not just loads of people, but also loads of fields, like loads of age and sex and like email address and all this shit, and I don't know what they liked, and massive tables of data. And so it's, do you split so that you have all people, or most people in one, so that every computer gets to see for every person a select few fields, or is it every computer gets to see every field for a select few people? Well, I should say records to make it more general for database terminology. So that kind of thing, and also voting. Well, voting? When I say voting, the computers vote amongst each other to see which one has the most up-to-date data. Because you have the trade-off between having data that's easily available, in the sense that it can always be accessed no matter what server errors you have, what's breaking down, like fucking Discord, for example. Usually, if there's a server outage, you cannot access the server at all. Whereas on like Facebook or something, that doesn't happen. But at the same time, if you have to have the redundancy, right? That you have loads of the same data stored in various places. If you want it to be that if one of them goes down, you still have the availability. And so keeping them consistent, right, up to date, is a way of saying that. Consistent. You have that trade-off. And so obviously if every computer had everything, that would be fine, but that's not feasible because of scale, because of how much demand that these websites and things have to serve. And so it's in what way do you partition stuff, and how do you deal with consistency and availability and that kind of stuff. Alright, that's my introduction to distributed systems. I'm not going to bullshit any longer. I still don't know half of the meanings of the theorems. I think I'm saying it right, but I don't know. Let's find out. Yeah, I'm going to try to keep fairly chill. Going to try to avoid having dead air or whatever, but I don't want to get too gassed about whatever I'm doing. Like, I have to stream this, make sure I get it right. So I'm gonna take it easy, or at least that's what I tell myself. Take deep breaths as well. Yeah, pretty much. So what this course. So I said somewhere on my stream description. If you're on desktop, you'll see it. If you just scroll down on Twitch. I said, I first got the idea off Reddit to do this course in particular. Someone said, if you want to do a hands-on course, go for this one, without bothering with the lectures. Well, I'll probably need to be reading the lectures, but I'm going to do it more just in time rather than actually formally learning anything. And also, so I shouted out on my Twitch page, this YouTube channel of a couple of guys who tried distributed systems, and they did a live stream as well. The two of them, they didn't have the whole broadcasting picture-in-picture shit that I'm doing. Just vibrated, but nonetheless, they did it that way, and they seemed to. I mean, I didn't watch it. Don't expect anyone to watch this shit, seriously. It's completely experimental. It could well completely fail as well. I could be completely out of my depth doing this. But nonetheless, they got through the first two topics, I think. I don't know what happened after that. They sort of stopped streaming, but the first two labs in about 10 hours, I think. But they're actual comp schemes. It'll probably take me longer. I'm hoping I can do one lab in 10 hours. That's the dream, because then if I push myself, I can get it all done by the end of, by the time, by the Russia-Saudi Arabia match or whatever it is, day one of the World Cup on the 14th. I might actually visit Cambridge between then and now, don't know, but I'll be in Cambridge on the 23rd for guest night as well, and or only that, I don't know yet, probably only that. So yeah, pretty much. What this is, I guess. I mean, I'll start reading it slowly. Read the actual lab. Well, actually, hang on. Yeah, there's no useful information here. The labs themselves are on. I'll give a quick overview. This is MapReduce. Lab number 2 is on Raft, which I always in my head I always just think of it as fucking Raft. I've just got so many. I've gotten so sort of used to seeing American streamers, particularly video games. When I watched a few Smash UK streams the other day, someone commentating Smash games, and it was just so nice to have them in English, English, not American. It barely counts as English. I mean, that accent I just cannot abide by, honestly, but yeah, that opinion. So it was just kind of nice to have that. But I mean, I had a Hungarian friend who could barely, well, he could speak English, but like he'd get completely, he'd lose the ability to speak English if he ever got drunk or stoned or whatever. And so he went to America for an internship, came back speaking like water. Can I have a glass of water? Water. So yeah, as a tribute to him, Raft is now Raft. Cool. Number 3 is, well actually, labs 2, 3 and 4 are all about key value storage, I think. Well actually, I think 2 might be purely, sorry I'm flicking through these quite fast. Yeah, a series of labs in which you build a fault-tolerant key value storage system. In this one, you implement the protocol that I think synchronizes them. I think this is what this does. This is the whole voting system shit that I was talking about. Number 3 is the actual key value storage service. And number 4 is something that allows sharding. What is sharding? Partitions over a set of replica groups. What does that mean? I don't actually know. It's a subset of the key value pairs. Okay, so yeah, so this is in my database. When I was describing how you might split a database by records or keys. Keys? The keys. Yeah. When I was describing how you might split a database by records or fields, this would be like the record split. This does not have fields. It's a key value store is like a dictionary, or I'll happily try to explain things slightly for non-Chomsky type people. I'm not a Chomsky, but whatever. A way of storing data, right? A dictionary, an associative array. These are words meaning, in programming, a way of storing data such that you have a key and a value for each key. So the keys are all distinct and values are some things associated to those keys. So it's like lookup tables. It's like, I have loads of examples of this shit. Let me just quickly dig one up. I'm using the Cortana box as a way of visualizing where my picture-in-picture is on the stream, so that if I just make sure I'm not doing anything in that particular part of the screen, then everyone can always see everything. What was I gonna do? I was gonna, shit, this is the wrong computer, isn't it? Sorry. Yeah, I'm just gonna simulate what I was gonna do. I was gonna, for one of my Pokemon Go projects, you would have lookup tables along the lines of, okay, this means lookup table, put some tabs in, and then it's like, oh, 1, that's the key, and the value is fuck's sake, Bulbasaur. Okay, this isn't the easiest laptop to type on if you have the fucking box at the bottom, but it hasn't overheated yet, so this is tipping in that direction, so I want to push this in that direction. Hang on, just move it. Yeah, it's better. 2 is Ivysaur, 3 is whatever, that kind of thing, right? And so this is what an associative array looks like, and so you store data in that form, so that you can type your code along the lines of, oh, okay, I'm just dealing with the Pokedex number, but anytime I need to, my Pokedex number is like and the math in me is just looking at that, like, Pokedex number is N, and then your that's the key in this case, and from that I can extract a value by typing Pokedex square brackets N, and so this is just the name of the dictionary. And so, if I run, I can have N is 1, if I run Pokedex 1, then the computer will evaluate that to Bulbasaur. So yeah, you get the idea, it's pretty simple. So that's what key value store is. I guess what we're doing with distributed systems, we're going to be working at scale. So yeah, when we say that this is sharding, what we mean is like we have, say, Gen 1 on this computer, Gen 2 on this computer. Just maintain the Pokemon analogy because so you don't, it would be a key value store would be useless if you split it by like have all the keys on this computer, all the values on that computer. That would just not make any sense. But yeah, like you can happily split it so that some bits are on some other bits. Some parts, some keys and values, key value pairs are on certain computers, and that's what the shard is. That's what it says it is. Sorry about my nervous crying again. There was yeah, there was totally a time I would have been embarrassed by that, like when you're a self-conscious teenager, but I mean, it's just how I am, and it doesn't bother me too much. I don't actually do it that much in public. I guess sometimes I do, but not that much with people I'm actually comfortable with, and so the live stream is like, fuck knows who's watching this, and I'm not, I said to myself I'm not going to check. Like every now and again I could check the chats, nothing in the chat room. I could do that quite happily every now and again. Reply, if I get stuck and someone's watching, that's probably not going to happen because, like I said, it's going to last 10 hours. Not today, but like over time, it's probably going to last hours and hours before I get anywhere substantial. But if anyone happens to tune in, because the idea is you just drop in and out of the stream on Twitch. If anyone happens to tune in with an answer, and I alt tab like, oh, I hope somebody can help me, and then like, there it is, the answer. Well, maybe not, probably not. I mean, I should really do everything myself, shouldn't I? But yeah, if any Komskis are tempted. Yeah, okay, well, there's a fuck ton of stuff to process for each of these labs, but we'll start with Lab 1. Lab 1 is independent, I guess, of the other three in the sense that these builds to something, so we said Raft is like the underlying consensus protocol, consensus being the voting thing. This is the key value service, and this is the sharding of the key value service. This is something completely different. Lab 1, MapReduce. So the functional programmers in the house will tell you all about map and reduce. Yeah, these are just ways. I mean, functional programming is just a way of thinking, I guess. It's like yeah, what is a function? Like if you've not done maths or programming, then you'll be lost at the idea of a function initially. But if you think back to reception, sitting in like the pairs classroom or whatever the fuck, your teacher comes out and says like, oh, 1 arrow 4, and then it's like 2 arrow 8, 3 arrow 12. What does the arrow do? Like this shit, and that's basically what a function is. You take something, do something to it, return something. In maths. In programming, a function, well, it can mean a bunch of different closely related things, but in the general sense, you run a function, you put something in it, those are the arguments, it does something to them, but it doesn't necessarily just do something to the arguments, it can also affect the rest of the program. Here we go, the actual fans have started. How can a computer run at 90 degrees? Yeah. So in maths, that's the simple kind of function. It always just, you put 1 in, you get 4 out every time. Shit, that's really taking off. You put 1 in, you get 4 outs every time. Sorry, let me just check what's happening with the CPU. And I think that might just be a momentary blip, like when it just starts, I don't know, dissipate. Well, some fucking service probably ran, and I don't know, like, it runs secret services all the time. Secret service. Ah, fucking. Windows can fucking kill itself. Where is that? This, yeah, fucking disaster, seriously. I'm out here trying to keep my laptop cool. Is there a service or something that's run that? I can't remember. Usually it's like, I can't remember the name of the thing, but there's a scheduled task that runs that fucks shit up. And just randomly starts like doing this, but I don't know. Let's have a look. Obligatory interruption just to deal with Windows Update. It's cooling down. It's cooling down. I mean, it's better than Windows restarting itself in the middle of a stream. If you haven't seen this happen, you should check it out. It's fucking ridiculous. Like Windows. No. It was someone was running Windows 10, Windows 7. And it just auto updated itself to Windows 10 while he was streaming an FPS or something along those lines. And he's sitting on the stream like, I thought we turned everything off. What the fuck? So yeah, I feel a bit like that guy. It's not nearly as serious, but yeah, I ended Windows Update. I fucking ended it right there. It seems to be fine now. Well, it's still trying to cool down. Temperature is now 70. Yeah, 70 degrees is fine. I'll take that, you know. The only time I expect that to happen while I'm streaming, it's quiet now, is when I'm when I'm actually running the program, right? Which is, you know, it's going to take a non-negligible amount of time because we're simulating workloads for, you know, large distributed systems. It's not your, you know, Python projects in maths coursework where it's just like, if you've done it in integer arithmetic, it will trivially do everything in about 5 seconds because the fucking recommended language was MATLAB, which took 10 times longer because it does not understand integers or something. It's a bit stupid, to be honest. Yeah, the hope is as well that I sort of habituate a bit to interviews and speaking and all this stuff, and then I get less nervous, less sneezy, less teary, all that stuff. That's the hope, and that should set me up for an interview. And if anyone's watching, it's also it's probably going to get a bit annoying, but at the same time, it's a nice exercise in self-acceptance, in my opinion. Cool. Yeah, sorry, Windows Update completely. What was I talking about? MapReduce and functions. Sorry, okay, maths. Yeah, so a function in maths is something like something that doubles numbers. So anytime you put a number in, doubling it will always give you the same number out. Everything maps to precisely one answer. 2 maps to 4 in the doubling function. And if you did maths GCSE and whatever, you would have plotted functions like x maps to x squared. You know, it looks like a nice parabola. Is that the right way around? Parabola. Yeah, it is. Parabola. Yeah, them ones. So in Chomsky, a function can have states. You know, it can have side effects. It can change state. It can be like, I run the function that like turns on a robot or something, and if I run it when the robot's on, it's not going to do the same thing. It's going to return a different answer. Like it's going to, for example, return an error code because the robot's already on, or it will just, you know, it'll return the piece of text saying already on or something like that. Another example I just thought of, not even a side effect really, is like the function that gives you the time. That depends on the state of the computer, namely what time it is. Um, and yeah, so if you run that once and then run it again 10 minutes later, completely different answer. So that is not a pure function. It's not a mathematical function. So in Chomsky, a function is the general term. A pure function is the maths idea of a function. And so functional programming is about using pure functions in order to achieve programs that are kind of transparent in what they do. You know what's going to happen. And more than that, you can sort of pass functions around. Like in maths, a function is a well-defined thing. It's an actual entity. If you look at foundations of math, then that will tell you a function is a type of set. Does not matter, but the point is, it's a thing, just as much as a number is a tangible thing. It's a tangible concept. And so in programming, a function is usually an object. If you're thinking about functional programming, you can pass functions around. You can make things like x to x squared, you can define those as simple anonymous functions that you can pass around. They're usually called lambdas in programming. I'm not really sure why. Sorry, what lambda means compared to just anonymous function. Lambda being a term from computation theory, it's a machine, I think. Lambda calculus. It's a kind of simulation of a computer that someone designed to try to prove things about which mathematical functions are computable, make sense as Chomsky functions. In a manner of speaking, it's because I just said Chomsky functions are more general than mathematical functions. Of course not. Maths functions could be the most fucked up shit you're never gonna lay down on a computer. Yeah. So what is this shit then? MapReduce. So I'm just I haven't actually started reading through it yet. I'm just trying to give a kind of introductory explanation of what I think I know about MapReduce. So MapReduce in the sense of functional programming. Map is like I have a function like x to x squared. I have a list of numbers. So I was talking about dictionaries earlier. You can also just have lists. A list could be like Bulbasaur, Ivysaur, Venusaur. And I have a function, a pure function along the lines of take a word and return the first letter of the word. And so if I apply that to Bulbasaur, I get B. Cool. If I take the Bulbasaur, Ivysaur, Venusaur array and use its map method, and in the map method I pass in the argument being what goes into a function in programming. I pass in the function that takes a word and gives back its first letter, then the result will be an array that contains not Bulbasaur, Ivysaur, Venusaur, but B, I, V, etc. So that's what mapping is. Mapping is because you're using a pure function. You can map to all these different parts of the array independently of each other. So this is a detail, right? I mean, when you're actually running the code in the most traditional setting on a single threaded computer with standard codes, the usual way code is done, I don't know how to describe it, just normally. Then it will usually map will be implemented in such a way that it actually does a for loop or something. A for loop being do the first one, then the second one, then the third one, then the fourth one. So the array gets constructed. You have Bulbasaur, Ivysaur, Venusaur. The new array gets constructed along the lines of B, and then it does I, and then it does V. Or when I say a new array, it could be editing the array instead. Two different ways of doing the same thing depending on which language you're using. So Bulbasaur is now B. So yeah, the array, if it's being edited, Bulbasaur, Ivysaur, Venusaur goes to B, Ivysaur, Venusaur, then B, I, Venusaur, until it's done. You get the same results. Well, okay, that's slightly misleading. Sorry, the way I phrased that. Yeah, it doesn't matter whether there's a new copy of the array is made or if the original array is edited. Let's just stick to one. It doesn't matter. But the point is, it takes Bulbasaur, Ivysaur, Venusaur and gives back BIV. But it does not. That doesn't mean that it has to go Bulbasaur and then Ivysaur and then Venusaur when you're doing the code. So if you did it manually, that's probably what you would do, because you'd say like for loop over this array and then that just goes Bulbasaur, Ivysaur, Venusaur. But it doesn't have to be like that in terms of the result you're getting, because shout out to Imre Leader, it's just his mannerism of just when he's making a big point, he would just go because map is a pure that's not right, sorry, I didn't give it a name. So the function that takes a word and gives back its first letter, let's call it the first letterizer. Psh. The first letterizer is a pure function. So depending on what the input is it Bulbasaur, Ivysaur, Venusaur, it will always give the same answer back for that input. So Bulbasaur will always give B, Ivysaur will always give I. Therefore, obviously, it doesn't matter which order you do them in when you're changing them. And that's the thing about map, or really anything that maps a function across an array. If it's a pure function, which is usually what you use map for, and that's why it's associated with functional programming. Obviously you could do something fucked and then make it not work, but if you're using a pure function, the fact that it doesn't matter, and that's specified in the code by using the word map, it doesn't, it just maps, like it gives you the result, it doesn't matter how it's implemented as long as it always gives the same answer. Well, when it comes to performance, segue, distributed systems and that, what if, if we're doing some massive procedure that maps a function onto like a huge data set, instead of doing it all on one computer, all on one thread, instead of doing it all on one processor thread, a processor thread being, the processor executes it, it carries out a sequence of instructions, one after the other after the other. So if it's doing this, then it does not make, it can apply the function to Bulbasaur and then Ivysaur and then Venusaur, or like it can go backwards. It won't make a difference because it has to do it for each one. It'll take about the same amount of time. But what if we use our multi-core processor and say, like Gen 1 will be handled by this core, Gen 2 will be handled by this core. You're doing parallel processing, so they're getting done at the same time. It'll take half the amount of time, and all of the first letterizer instances are independent of each other because they only depend on the thing that's sent into them, that piece of data, Bulbasaur or Ivysaur or Venusaur. So what does that mean? That it'll take half the time if we split them over cores. And so distributed systems, we split over computers and run the same thing on loads of different pieces of data by sending out those pieces of data to different computers, and then the map will, whatever function you're using in map will be applied to all of those. So yeah, that's quite a lengthy explanation, but yeah, the idea is, if you do that, you're spreading the load over loads of computers, and map is anything you pass into that is independent. It'll be a pure function, and so yeah, performance boost, everything gets done more quickly, and that's what it's all about. Gonna actually open the window again to get more oxygen now that cunt bag with the diesel car or whatever it was is gone. Yeah, awesome. So I don't actually know what reduce is, but from just skim reading, I think it's the idea that once you've processed all this data, in the sense of MapReduce, reduce brings it all together to give you a meaningful answer, like to tell you something like there's this really trivial example. Word count, generally speaking. I think what it does, I haven't really looked yet, but I think what it does is it maps every word to 1, and then the reduce sums the results of all the map functions and gives you your word count. Yeah, not really sure. But what I will say is reduce is another common functional programming idiom, just like map. So I guess, it is a pure function, but it depends on the results of all of your map computations, and so I guess what reduce will be doing is taking many inputs and bringing them down into 1, I guess, I don't know. Another functional idiom is filter, which I use a lot to just deal with data, map and filter. So I mean, I wrote a program, a function that turns a bunch of text files into workers, so to speak. Every text file specified like a channel on Discord for this bot to post to, and so the function, all it does is it starts by reading like a person would the name of the text file, and then when it accesses the text file, all the things in there. And so applying map to convert the name of the text file into like because I had them in some format that was like this thing dot this thing dot this thing, so map can convert that into an array, because we map the like split function that splits a string according to dots. Dots are the delimiters of different bits of text, and so it splits them into a list where the first bit is the first bit up to the first dot, and then the second bit is the second bit, and that, right? And then filter would choose the ones that are like valid text files. There'll be a function that says, oh, okay, the Discord channel ID has to be 18 digits long, so that goes into the filter. Didn't need to use a reduce, because once the mapping and the filtering was done, we just converted all the shit into an object that represented the filtering, and then that was run by the bot. So I should say what the bot does, just briefly. This thing that I've spent like a year very on and off programming, takes information from a map, filters it, and sends it to Discord. That's all it does. Don't need to say what it is even. Well, the information is like from Pokemon Go maps, like wild spawns, raids, and that. But yeah, pretty much. So, just to process lots of data, it's useful to use functional programming, I think. You can just say what you want it to do, send in the pure functions, and like everything is just easier to read. And also you don't get bogged down writing stuff like, the actual procedural shit, like fucking for loop, I equals 0, I less than length of the list of shit that needs to be processed, and so so it's about changing your mindset. Yeah, it's about like saying, I'm not gonna even write down the counter variable. I'm not gonna bother thinking about this as being a loop of this thing and then this thing. I'm just saying, like, I apply this function to all this shit and get the result out without bothering to think about how I'm gonna do that. And so obviously the computer has to think about how it's going to do that, because like a processor just like does one, like edits memory and jumps and does one step after the other. But you, the programmer, it's basically abstraction. If you don't have to write so much detail, you just write down what you want it to do. That's the idea of a high-level programming language, and that's why you would want to use that kind of way of thinking for that particular task when you're dealing with lots of data. There are no side effects, you just use your pure functions. Oh, that ramble was fucking long for man. Like, I'll just take a quick break now, see how things are going. Still no chat, good. Still not gonna check how many people are watching this. I guess it's been an hour. So 50 minutes, I imagine, not that many, but You never know when someone will tune in. Alright, last, I hope this is the last bit of prerequisite, because I'm kind of aware now that like I only have an hour left of the time I was sort of intending to spend doing this. Last of the prerequisites is to talk a little about Go. So the programming language we're going to be using to do all this shit. So I'm going to be working in Visual Studio Code, which if I open this folder, I sort of gave the game away slightly, but this fucking, oh no, I thought it froze. Gave the game away slightly, but like when I list everything out like this, I wanted all of this to be visible on the stream, and what that meant was I had to put in these like files here, these Z, just to fill it out at the bottom so that it, it scrolls correctly. Yeah, else this would all be stuck at the bottom and it would be totally invisible. Yeah, the reason I called them Z is the last letter of the alphabet, and also just a shout out to Wolfpack, who released an album on Spotify consisting entirely of 30-second bits of silence, and there were nine tracks, and I think these were the titles, because the album was called Sleepify, and it was designed to exploit the Spotify revenue model of song plays for 30 seconds, that counts as a play, artist gets 0.004 pence. Is that? I think that's right. I think it's 0.4 pence. Sorry, still abysmal. One stream. If you're a up and coming artist, then you get 0.4 pence per Spotify stream. It's fucked. Yeah. I was gonna I'm not gonna. So yeah, Go. I did a quick tutorial of Go. It's a bit of a strange language. Well, it's pretty weird. I mean, the way it does concurrency is, I think, unlike any other language. So I had to get my head around channels and that. So I did a quick tutorial. I tried. I didn't actually finish it because A, it was really long, and B, the last exercise was just unnecessarily difficult. It required you to use, idioms of programming in Go that really from the rest of the tutorial you wouldn't be able to learn. You'd have to read around it, and I just thought, well, I don't give a crap. I mean, I did the other exercise, the one about traversing checking that two binary trees are the same by using channels. Still, I mean, it's kind of weird. It's a weird way of thinking. I got used to using Node JavaScript. The way it does concurrency, I actually learned that eventually after, some time. And it's pretty hard to get your head around at first, and I think it's going to be the same with Go. So I'm definitely going to be learning to use Go as well, which is going to make this a bit difficult. In this lab, you'll build a MapReduce library as an introduction to programming in Go and to building fault-tolerant distributed systems. You will write a simple MapReduce program. In the second part, you will write a master and workers, handles failures of workers, interface. This car comes back. I think that's the same car as well. I mean, maybe if my mum were not in like the next room, I would just like shout cunt at this guy or something, just provoke him. But it's just one of my biggest, one of the things that most pisses me off in life is people leaving engines idling. I find it incredibly disrespectful of the environment, pollution-wise, global warming-wise. People just sit there like browsing sat-nav or something with the engine on. Or worse yet, like I have a massive truck recharging batteries while you're trying to, I don't even want to say sleep, while you're trying to breathe, yeah? The interface to the library, and the approach to fault tolerance is similar to the one described in the original paper, which is not getting read, unless I have to, right? I mean, I'll quite happily cut the stream at some point and say like, okay, I'm out of my depth here, I need to like read this shit, and I'll do that off stream because sometimes you just need to not talk for a bit, but generally speaking, I think I'll give it a shot and see how it goes, and then see if I need to chill out and take it back. Just do a bit of the old vanity. Yeah, this haircut, is this okay? I mean, oh shit, this is the side that's bothering me. Wait, hang on. Yeah, I can go even further. I can be like, Yes, yeah, classic curly hair. No. Well, which side is which? This side is this side, isn't it? Yeah, it's like... Yeah. I promise the stream is not going to just be about that. Collaboration policy is not getting read. What's this? Please do not make your code available. Car cunt is back. Window is closed. I smell of kerosene. It literally smells of kerosene. Like, what the actual fuck? Like, how much effort would it take me to police that? To come and say, oh, you know, please hold for environmental services so they can get someone to perhaps come down and like deal with this twat. I mean, there's nothing I can do. It's just literally, I close the window and now smells of kerosene in my room. Fantastic, you know, just reminding me I haven't travelled in about a year. Okay, yeah, for the time being I made the Git repository. Well, I think it might have auto-made the Git repository, I don't remember, but I won't upload it to the internet. Maybe I will later on, just in case this computer dies. I'll put it on like GitHub or whatever. Be sure to create a private repository. Oh, but then I'd have to make a GitLab account. No. Allow it. But actually I checked, like the hand-in dates have just pretty much passed, so I think, you know, I'm not even worried, to be honest. The Go, yeah, so we have, you know, a bit of chat about Go here. We also have a bit of chat about their like architecture or servers and whatever, but Max and Ben seem to be okay just using the internal test suite and not bothering to deal with all this shit. I mean, I actually did manage to get an API key eventually, so maybe I can test stuff, but I can test stuff. I think it's equivalent. Like, I think the tests that they provide that you can run offline are the same as the ones that they provide to check you've actually done it correctly online. So it should be fine. No worries. We supply you with parts of an implementation that supports both distributed and non-distributed. We fetch the initial lab software. I've done that. Bit of shit about Git. Yeah, somewhere it says how you make it distributed and non-distributed. You know, one of them obviously if you have everything in a sequence, that makes it easier to debug it. That's why you care about non-distributed versions of the same shit. Done all of that. This is why I'm using Visual Studio Code, by the way. I don't actually really know how to use the debugger, but I can use the source control. Like, I just type something in, Control Enter. Sick. On the other hand, it's starting to take the piss, and I think the fucking linter is on or something, like something that just complains about code that's not been properly formatted. What is it even talking about? Like, if I right click this, lag there. Funny, using a cutting edge ultrabook, the lag, you get cutting edge software as well. So why the fuck has it underlined it? I don't actually know. Whatever, I don't care. You know, next when I go offline, I'll deal with all that shit. I mean, it's not important. So yeah, I mean, I should say I downloaded, via Git the version control system. I downloaded all of the source code from the exercise, the basic stuff, and here it is. This is it. So these files are not going to contain anything important, I don't think. What is a make file? It's something that handles sending, submitting code. Dear Lord, the lag. Something that handles submitting code to MIT. Not going to be using that probably. Well, as in I don't need to care what it does. And this is just ignore some files. Git only cares about that. So we only care about the source folder, which has loads of subfolders, which we will try to get our heads around. Did I scroll down? Yeah, I did. Okay. Yeah, I was just showing off the how things look in Visual Studio Code, and hopefully I'll learn how to use the debugger one day. Yeah. Okay. Here we go. Yeah. Sequential and distributed. This is what we were saying earlier about there being a sequential mode for debugging. In the former, the map and reduce tasks are executed one at a time. First the first map, then the second, and when all the maps are finished, the first reduce is run. So we have some idea of how the non-distributed version is supposed to run. When all the map tasks have finished, the first reduce is run, then the second. This mode, while not very fast, is useful for debugging. The distributed mode runs many worker threads that first execute map tasks in parallel, and then reduce tasks. This is much faster but also harder to implement and debug. Yeah. Big learning experience learning to implement a web app in asynchronous JavaScript. Asynchronous being basically a way of saying not synchronous, synchronous, sequential. Same thing as far as I can tell. So you get the idea. I mean, because you spin up, things get parallelized, run concurrently, and then if something fails, you don't have the feedback because it doesn't block. It doesn't just crash the program. If you're running in one thread, if you're running sequentially, you can think of that as like I run this piece of code and then I just wait to see what happens. I'm watching it all the time, so if there's an error, it gets thrown straight in my face. Whereas if you're doing something concurrently, then what you're watching moves on. It sends off the task to be done somewhere else. And so if it fails and you've not handled that correctly, it can just get lost. Debugging that, what you will be getting is programs that just deadlock, really. They just hang up, they just stop working, but you don't notice that they've stopped working. No error ever comes back. So that's why it's hard to debug concurrent programs. And distributed, what that means in relation to concurrency. Concurrency is just the general idea of not caring about what order things happen in, what I was talking about earlier. But distributed is when you do the concurrency across loads of different computers. That's all it is. So yeah, that's what we just said. Many worker threads first execute map tasks in parallel, and then the reduces. This is much faster, but also harder to implement and debug. Here we go. I think generally when streaming, I'm going to try to take breaks. So I've done a lot of talking. I don't feel like I've done a lot of actual work yet, but nonetheless, it would be good to get into the habit of taking breaks. I'm not actually sure how I'm going to take breaks. I think the idea I had was that I might practice speedrunning Super Mario Bros. Maybe for example. Where by speedrun I mean let's first try to actually finish the game. I've never finished it. It's too hard. And then, you know, just have something to just do, to just chill out between work, because it's good to take breaks. And I don't have my phone. If I'm streaming the whole time, I can't just do stuff on the computer. Well, I guess I could mute it, but that I'm not going to. I'm just going to keep the stream going. So I'm not going to procrastinate on the computer. I'm not going to procrastinate on the phone because I'm using it as a webcam. And so yeah, just do something slightly more constructive, like say Super Mario Bros. Record. Just today actually, I think, or was it yesterday, one of those days, someone set a record, a world record. It's getting very, very optimized. Pretty famous speedrun. But yeah, never mind all that. Let's take a quick break. Stream still seems to be working as far as I can tell. I got a comment. I thought, what the fuck is this? I don't even know when this comment arrived. And someone sent in a kappa as well. T1 dot equals T2. It's talking about unit testing there. It's not particularly relevant to what I was talking about, but cool. It's cool that I have a comment. What I want to know, and I'm going to actually look into this, is how I can get a pop-up permanent comment stream. I think I probably don't want to be using the streaming software. Maybe I want to just open a Twitch client, but try to get it to only stream the comments, like the chat room, and not the actual thing, which I'm just going to hope is working. Seems to be working. I can zoom in the camera slightly. This comes down in order for it to go up. It's in reverse. Yeah. So I'm just looking into. Do I want to, while I'm live, make minor adjustments to lag and synchronization and that kind of stuff? Because at the moment the actual camera seems to have lagged slightly in comparison to what it was, and so I guess you have to just get a feel for how big the lag is. Let's do that. I'm just gonna guess. So I'm gonna delay the audio by another 15 milliseconds, and I'm gonna delay the video capture, this shit. In order to do that, oh no, I want display capture. And I have to go to filters, click on the delay, and chuck it to 200. Ooh, fuck, sorry. 200. Cool. And so now if I do this, hang on, I'm looking at the wrong thing. The sync is actually, you can see in the infinite stream thing, you can actually see that all of them are sort of ticking at the same time as each other. So my idea is that I'm synchronizing pretty much the audio from the microphone to the display capture, right? So I'm hoping, because the microphone is actual dedicated hardware, that if I what was that? That was 200, wasn't it? Sorry, I'm not thinking. That the lag on the microphone isn't gonna change much, so it's on 380. The latency isn't gonna change on the screen capture and the microphone. That's what I'm hoping for, and this is capricious ass camera over here, much more likely to change. So therefore maybe I can resynchronize it and see if that helps, but I mean It's a minor thing. I'm not going to get too hung up about it. Maybe every hour I check that, you know, because I want to actually, despite what you've seen so far, I want to actually be working. So I'm just, because I'm doing a slow introduction, not that much work is getting done, but yeah, pretty much. What is going on? I don't know, I probably should just have that minimized. It's messing shit up. Yeah, so maybe I'll dig up Super Mario Bros. Or Super Metroid even, or I don't know, something. Super Metroid I still need to 100% it, and I'm trying to do it blind, and that's fucking difficult because I got it 95% without really trying, and so now it's an entire empty cavernous world, and I went looking for shit at random for an hour and a half, could not find anything. So yeah, in the event that I have someone who is watching while I'm doing, like, say, a Super Metroid, while I'm messing about with that, they could try to guess, for example, where items might be lying, and then I could go out and find them, perhaps. Don't know. Not going to worry too much about it, but cool. For the time being, yeah, that was a bit of a boring break. Like I said, I'll see if I can make them more entertaining in the future, but for now I'll actually come down and get to work, because I haven't actually done anything yet. Okay, I'll go for another 45 minutes or so, and then I'll call it a day for now. Despite not having done much work today, I expect it to pick up a lot in the future. Whoa. This is slid. Cool. Try to come up with a better solution to the laptop thermals as well. Preamble: getting familiar with the source. Yeah, I don't know if this bodes well for like a software job, but looking at other people's source code is just gonna have to happen. But I so prefer just doing everything by myself. But such is life. So let's give it a shot. Ow, crap. Oh, fuck. My leg. The map. I give up. The MapReduce package provides a simple MapReduce library. In the MapReduce directory. So we have a MapReduce directory. This is what it looks like. The application should normally call distributed, located in master.go to start a job. Getting fidgety because I know I'm actually doing work now. Application should normally call distributed to start a job, but may instead call sequential, also in master.go, to get a sequential execution for debugging. Cool. Package MapReduce. Please do not modify this file. Okay, so this is the kind of framework that we're working in, I guess, the main file. We're not modifying it, so let's just get used to it. Import FMT. FMT is the text, standard output. That's what it's called. So when programs print stuff somewhere where you can see it, consoles, you'd use FMT for that. Net does some, I don't know what net does, probably something network related. Sync is a package that has concurrency related methods. Method, by the way, is a type of function. Usually you think of a method as subordinate to something, whereas a function is more like, I can pass this around, like I was saying about the pure functions. So yeah, sync has some methods for concurrency. Master holds all the state that the master needs to keep track of. Master is a struct. A struct being, an object, a thing that has lots of parts. That's what a struct is, in the most general sense. A thing that has lots of parts. Mutex, mutual exclusion, lock, means that this thing, if we write sync.mutex, that means that this struct can be locked and unlocked by different threads. So threads are like, in concurrency, or code running in lots of different places at the same time. It's usually captured in threads, as in a thread will be running a piece of code sequentially, and lots of threads give you concurrency, right? One thread sequential. And so the idea of the mutex is that I have an object, loads of threads can use it, but if two threads are using it at the same time, it can get corrupted. Mutex means that one thread takes control of it, the others cannot edit it, it locks it, and then it can unlock it later on, so that another thread can take control. It's the problem with shared memory in general. When you have concurrency, you have to use mutexes, that kind of thing, to keep control of, to prevent what I just mentioned, data corruption, when you share memory. And mutexes are very expensive. They're said to be expensive. That's a kind of rule of thumb. They are expensive for the processor. Switching, unlocking, locking. So you want to, more modern concurrency paradigms tend to go with, like, instead of sharing memory, what about sending messages from one to the other? Go does that as well. It has channels. Use channels for one thread to send a message to another thread. Easy. Well, it's actually quite difficult in practice, like it fucks with my head, but never mind. That's what our mutex is. Okay, so master is, I guess, just the master. This represents, objects in programming represent things. If you imagine a program as like an office, master is like the thing that runs the entire MapReduce task. So that's what this is, and it has a mutex. Address is a string. Okay, string being text. For all intents and purposes, string is just text. Done channel is a channel, a Boolean channel. So channels in Go, different threads doing different things communicate by sending messages via channels. Channels are typed. Everything is hella typed in Go. Meaning they can only take bools. And what a bool is it's a data type that is either true or false. So you just use bool to represent true or false. String represents text. So this is a Boolean channel. Done channel. Therefore, in this channel you can send a message that amounts to the word true or false. Not really a word. It's just an abstract, true or false. You can think of it as 0 or 1 if you want to. What's going on? Protected by the mutex. What is protected? What the hell is this? New cond. Sync.cond. I don't know what a cond is. Signals when register adds to workers. Which one is register again? We just had that, didn't we? No, we didn't. I should probably read this, shouldn't I? First. Okay. Yeah, whatever. Yeah, okay. Well, it says here they should call distributed or sequential. Let's have a look at distributed and sequential. So we have some functions, they do some shit. Here we have sequential. More shit. Here we have distributed. This is fucking deep, isn't it? As in, it's going to take me a while. I'm not sure how much of this I'm supposed to understand. This is, don't forget, we're not editing this. This is just the background stuff that allows us to do what the exercises are in the actual task. But, like, I don't know how well I'm supposed to understand that, the background stuff. Sequential runs map and reduce tasks sequentially, waiting for each task to complete before running the next. Yep. And distributed does Where is distributed? What is distributed called? It's not called distributed, it's called... Oh, it is called... Mate. It is called distributed. Is it here? Kill workers... Run... Here it is. Schedules map and reduce tasks on workers that register with the master over RPC. RPC, don't know what that is yet. Remote procedure call, I think it's supposed to be an internet protocol for a program running on loads of different computers to coordinate with itself. So one computer, the instance of the program on one computer will send a remote procedure call, run a remote procedure call, and what that does is it runs a function from a different computer instance of the program. So when we say master and workers, master will be running on one of the computers, worker on another one, something like that. I don't know. But yeah, remote procedure call is basically, for all intents and purposes for now, a way of the different bits of the program in different computers to communicate with each other. Yeah, okay, cool, that's fine. Cool. The code executes the job as follows. Here we go. Fuckeries begin. The application provides a number of input files. Input files are going to store the data we want to process, a map function, that's our pure function, a reduce function, and the number of reduce tasks. What is a reduce task? Don't know. We'll find out later. I don't actually have to know everything at every stage, it's just about figuring things out. That's why I'm doing stuff the practical way without looking at the theory first. The master is created with this knowledge. The knowledge was thus bestowed upon the master. What the fuck is this sentence? It starts an RPC server. Today I learned RPC is done in servers. See master RPC. Okay, I guess this is what runs in the server. The RPC server. Yeah, master.go. I would presume this is the program that is run. As in, this is where the program enters. On any computer that's running the master. Master.rpc, I guess something has to run a server for remote procedure calls, and that computer will be running this file. Okay, cool. Today I learned. It starts the RPC server and waits for workers to register using the RPC called register. Also defined in master. As tasks become available in steps 4 and 5. Okay, later. Schedule. Is this just like each one of these files is being run by a different computer? Not necessarily. I mean, when I design programs, I have lots of different files that are kind of modules, yeah, literally modules that are run by other programs. So some of them are executed, but some of them just provide extra functionality, extra functions, and such. So just quickly, I've noticed like the camera shakes quite a bit. I'm not sure if that's a huge deal. At one point, I had my heartbeat so high that the bed was shaking, and so the camera was just doing this. Nonsense. General disaster. I'm glad I have all these fucking tortilla tissues in it. Just from the last time I went to eat burritos in Hammersmith. Yes. Now that I've done that, I just have to check that the webcam is still focused. Yeah, looks okay. Where was I? Yeah, so we have a register that registers workers, we have schedule, and these are all... Well, schedule is actually... Yeah, it seems to be that schedule is another computer. I don't want to call them computers. There's another word that I'm looking for. So master, worker, RPC server, these are all types of what? I'm glad chat is dead because I don't really have a way of watching it. I'm gonna fix that. I'm gonna make it a bit more watchable. I'm not sure if this counts as audience interaction, but let's just give him a quick yes. No tests will. Whatever. Actually, I don't know what to type. Unit testing is really not a thing that's going to be a thing, but I don't know how to say that in a funny way. Let's just. At least this means that it's probably working. At least I hope so. I don't know if anyone points out streams that are obviously fucked, but okay. So yeah, schedule server, RPC server. Don't know why there would be a schedule server. I don't know. I'm not going to speculate. I'm just going to keep reading and then we'll find things out later. The master considers each input file to be one map task. Yep. Map task, I guess, is just like another layer of map. The thing that the map function being applied to a piece of data. I guess, that is visualized as a task. Not necessarily like one item in an array. It's just a task that is, generally, it's independent of all the other map tasks, and we have those kinds of principles. We'll see all this quite vividly when we do when we do the example on word count. Okay, input file is one map task. We call doMap, which is in common map. I guess map is the map function. It's stored in common map, makes sense. At least once for each map task. It does so either directly when using sequential or by issuing the do task RPC to a worker.go. Worker. So yeah, do task is a remote procedure call that goes to a worker. Master sends it to worker via RPC do task, and what the task is applying map from common.map. So now I'm thinking common.map is probably more, common_map, common map. That file is probably supposed to be a module, an actual, something that's shared and loaded into all of the actual masters workers that run whatever other files they're supposed to be running. So yeah, it's a module, it's a helper. It contains the map task that the worker will need to know the map task. I don't think the map task gets sent over RPC. I think that's actually loaded into the worker, presumably. Let's find out. Okay, so sequential does it directly, meaning when we're debugging, we're just going to be sitting on one computer calling doMap. Doesn't yet. I mean, when you're running one thread programs, it's just everything happens in order, in the order you write it down. It's good. It does so either directly when using sequential or by issuing the do task RPC to a worker. Each call to doMap reads the appropriate file. Where is the appropriate file? Don't know. We'll find out. Calls the map function on that file's content and writes the result in key value pairs to MapReduce intermediate files. MapReduce is the number of reduced tasks. I guess it's like a kind of you don't necessarily want to do all of the things, all of the results of the map stuff are not necessarily all going to be reduced into like one result at once. You might instead get like a tree of reductions where things get merged iteratively in some sense. And so I guess reduced task, I'm visualizing that at this point in time, I'm visualizing that as kind of a tree with two layers. So at the bottom, the leaves are all the results of the map tasks, and then the layer above that is the reduced tasks, in the sense that all, some of the map tasks go into one reduced task, like branches of a tree. Tree is like, the Chomskys out there will be able to visualize trees because those are like a standard data structure. But I'm doing the whole hand wavy shit just for everyone else. And yeah, so we have n reduced tasks, which each handles a bunch of map tasks. So all the map tasks are bundled into reduced tasks. N reduced tasks. And then the top layer of the tree is the n reduced tasks are all bundled into one result, I think. I don't know. Maybe. Peut-être. Where were we? Writes the resulting key value pairs to the n reduced intermediate files. Okay, files. Do map. Which one is do map? It's the one that executes the map task. Hashes each key to pick the intermediate. Okay. Yeah, do map. Hashes each key means we have a random function that takes the keys. So don't forget, we are. Let's say that we have. I think this is what this is alluding to. We have loads of data, and we need to apply map to all of it. So I was, in my example, I was talking about doing it to a list, but we could also do it to a dictionary, obviously. So instead of like the Bulbasaur, Ivysaur, Venusaur list, we have the dictionary, and that is identified by keys 1, 2, 3, and the values, namely Bulbasaur, Ivysaur, Venusaur, those are getting the map task applied to them. So I think that's what key means in this context. Hashes each key, meaning 1, 2, 3, all these numbers are run through a function, another pure function, that outputs a random number. And the idea is that even if like the numbers are close to each other, the hash should give wildly different results. And the point of that is that you get equidistribution, no matter what structure there is in your keys, values, whatever. The hashes will be random, but also, because they are all numbers in principle, or some other data type, they have an order, and so you can just bundle those into boxes based on which numbers, like the top 20%, the next 20% of hashes, whatever. And using that, you can assign each one of those boxes to the intermediate file, and that's how you pick the intermediate file, by doing that in such a way that essentially it tries to equipartition. And that's the whole point. That's what, when you're doing a distributed task like that, you want the workers to load balance. You want nothing to get top heavy, because the speed of all of your MapReduce tasks, all of the computers running maps separately from each other, the speeds of all of those basically are the speed of the slowest one, because they're running in parallel on separate computers. The slowest one is the speed of the whole thing, and obviously if you distribute evenly, that will minimize the slowest one. The maximum speed will be minimized by doing that, which is, the math in me wants to prove that, but like, it's obvious. Yeah. And thus the reduced task will process, so what we said is pick the intermediate file, and therefore the reduced task that will process the key, because each reduced task has its corresponding intermediate file to store the map tasks. I guess maybe for clarity, I should say something along the lines of data, arrow, map tasks, arrow, intermediate file, arrow, reduced tasks, arrow, result. we're mapping, and then we're reducing, just to keep it clear. That's the thing that we're imagining. Because I'm not doing too much writing. I have some paper here. I could pick up the phone and write stuff and show it to you if I wanted to. I can use the touchpad to just very quickly slide between shit. Because most of the reading is happening here. So I can just do this if I want to and have the stream chat up while I'm reading. Why not? Okay, where was I? This is a long paragraph. It's not that amenable to reading it all at once. We got to here. There will be n map times n reduce files after all map tasks are done. Why? What the hell is n map? Oh shit, yeah, n is, sorry, they're not thinking of n as a variable, they're thinking of n reduce as a variable. It is the number of reduced tasks is called n reduce. Same goes for n map. But what is n map? I don't think it's the number of map tasks, because shouldn't there be one task per piece of data? Maybe it is it doesn't say, does it? If I control F n map, it says nothing. This is the first, oh fuck's sake, almighty, fuck's sake. Okay, so I'm thinking n map is the number of map tasks. Why is it n map times n reduce though? I would have thought when you do all the n maps, they get sent into the equivalent n reduce. The equivalent reduce task, and that gets bundled into one file. Does that not happen? After all map tasks are done, there will be... Okay, each file name contains a prefix, which is the map task number. This Windows Update started again. You just tell from the fucking fan. Sorry, bear with. No, it hasn't. Laptop's just naturally overheated, probably because the fucking Windows too not open enough. Let me just... Yeah. Georgian window, isn't it? Gregorian? Gregory's a fucking pope. Georgian window. Slides up at like... It has a huge amount of friction on it. Yeah, okay, the map task number and the reduced task number is in the file name, so it looks something like this. Map task, reduced task, prefix. If there are 2 map tasks and 3 reduced tasks, the map tasks will create these 6 intermediate files. 0s and 1s, 0 and 1 are the map tasks, 0, 1, 2 are the reduced tasks, so we have, the Cartesian product. Sorry, mathmo. Basically all of the pairs of map number and reduced number that are possible are listed here. So there's a file for each possible pair. Yeah. So I don't know how these files are used exactly. I guess most of them are going to just be empty. Surely each map task gives a result and sends it to the correct reduced task. And which reduced task is determined from which map task via hashing. I don't know. Each worker must be able to read files written by any other worker. Sorry, eyes. Each worker must be able to read files written by any other worker, as well as the input files. Cool. Sounds like slightly stronger than you need it to be, I don't know. Real deployments use distributed storage systems such as GFS, I think that stands for Google File System, to allow this access even though workers run on different machines. So you're using a different distributed algorithm or storage system in addition to MapReduce in order to coordinate the storage of all this shit. In this lab you'll run all the workers on the same machine. Yeah, distributed my ass. Use the local file system. Why? Because why not? RIP. Press F to pay respects. Yeah, this is if I were streaming, if I was streaming video game and had a following, I just Twitch chat would just be like F F F F F F F F. The master next calls do reduce. Okay, yeah, the master next calls do reduce. Okay, let's have a look at the old system here. Do reduce, which is in common. Oh yeah. So I get it now. So common is the modules, isn't it? Common is the stuff that every program needs to be able to load. Master. So I still don't know. I feel like if the thing before the underscore should be the program. Worker, master, scheduler. But then you have RPC, isn't that supposed to be a separate program as well? Separate computer, sorry. Doesn't matter. Common is common to all of them. Common is the static, the functions that everything can access. So master next calls do reduce, which is in common reduce. At least once for each reduce task. As with do map, it does so either directly or through a worker. Do reduce. So if I run through something really fast, I get a paranoid that I didn't read it right. That's just OCD. I do have OCD, like legit OCD. As with do map, it does so either directly or through a worker. The do reduce, yeah. Oh, I see. So, how do you debug workers if everything's sequential? I mean, if it's not using them. Never mind. Do reduce for reduce task R collects the rth intermediate file from each map task. Collects for reduce task R collects the rth intermediate file from each map task. Okay, possible confusion between doing lots of reduce tasks for one thing, for each piece of data, and which worker is handling which one, and those two having possibly corresponding to n-reduced files and things we don't care about yet, because it will become obvious what's what when we see the examples or whatever. Yeah, so do reduce for reduce task I collects the rth intermediate file from each map task. The rth intermediate file. I guess that means R corresponding to the n-reduced number. And calls the reduce function for each key that appears in those files. The reduce tasks produce n-reduce result files. Well, there are n-reduce tasks, therefore there should be n-reduce result files. There should be a network diagram somewhere. I'll see if I can find one later. Perhaps put it up on the stream. But this is really not clear without the diagrams. Master calls mr merge. Master split merge. Split merge. Oh, I guess because it also contains a split routine. So there's a merge. What? No split routine. What's that about? I don't know. So many questions, so few answers, and I'm crying again. Let's get a new tissue. I think, what is it about? I think about social anxiety. I think it's any time I feel like I might actually be conveying my own personality a bit, and not just running through the motions of speaking about whatever's on the page. That will get me excited and crying. When I'm sort of speaking to God knows who on the internet. Was that lightning? Random flash. But I think, sometimes if I talk to myself, even without recording it, like the same thing will happen. Thunder, yeah, thunderstorm outside. Yes, I love me a good thunderstorm. So yeah, that's just the thing. I think the more I get used to it, it'll probably stop. It'll come down. But because it doesn't actually really bother me, other than being slightly inconvenient with the tissues, it doesn't. I'm not fussed. Cool. MapReduce result files. I'm gonna have to read this again. I just know it later. Master calls MR merge in split merge. No idea why it's called split merge. Merges all the MapReduce files produced by the previous step into a single output. Yeah, so my suspicion the whole time was there is a single result to all this shit. Master sends a shutdown RPC to each of its workers and then shuts down its own RPC server. What did you mean its own RPC server? Is that running on this I guess the master computer that's running master may also be running the server itself. Maybe server is actually handled by the master program. Maybe it's a part of it that's just running in parallel. Not parallel because it's probably single threaded. It might not be. It could be two threads, one piece of code, like as in one file. It could be anything. That's the point I'm trying to make. Like fuck knows. I don't. It does not matter. But yeah. Okay. Over the course of the following exercise, you will have to write modify. Here we go. It tells you what you're going to be modifying. Do map. So do map. Okay. Do map is not the actual map task, is it? The actual pure function. Yeah, because if you see what it says here, do map reads files, calls the map function. Yeah, so do map is not the same as the map function. The map function we're not going to have to edit. I don't know where the map function is actually stored. Maybe it's here. We have do map. Mapf. What the hell is this? It's a function, but it's written as a interface type thing. It looks more like a specification of methods. There's a fuck ton of text to read here. Lightning again. You can't really see the lightning. If I turn off the lights. Wait, this has dipped a bit too far. If I turn off the lights. You know what? Let's have the lights off just until the next lightning strike. Fuck it, the next lightning strike literally just happened and there was no light visible, so fuck it, the light's coming back on. I just thought I could go for a bit of atmosphere, a bit of, shit. Just set the camera up again. Microphone. Cool. See the microphone now. This little knob at the bottom of the screen. Yeah, I'll read through this later. I might even not bother reading through it on stream because it just seems like loads of details that I can... It would probably just make the stream too much of a slog if I read it on stream, so I might read it afterwards. I'll see how it goes. If I want to be completely transparent, I should read it on stream, then it'll be like, yeah, I'm not even, I'm not doing anything outside of what's on the stream. It's like live streaming that, like, 100% Batten Kaitos run, you know them ones. For context, that run literally includes the sleeping because something has to happen and it takes over 300 hours. And so there's a lot of idle time while waiting for that to happen, and the speedrunner uses that time to sleep. And so he or she tried to stream the entire run, but got shut down by Twitch for non-gaming content. That was kind of a famous joke event that happened. So yeah, A can't do that. Instead, A streams 4 hours a day and then moves it onto some other soft service or something, but therefore there's no like complete 300 and whatever instance of the run anywhere on the internet. You can't store it. You can't store it on a hard drive either, because there's not going to be enough space for 300 hours of nothing. Because it's all, you know, an actual game, so it's a lot of space used up on storage to store that. Sorry, I don't know what that digression was for. Something I was reading about today. Yeah, we will be editing, that's what we were talking about. Do map, do reduce, so the mapper, the reducer, the scheduler, it's not even that many things, you know. Why not write an RPC server? Is it too hard? I don't know. These are located in common map, common reduce, and schedule. You also have to write the map and reduce functions, which are stored where? Main wc.go. Yeah, because wc stands for word count, and that's the example of the MapReduce. That's the case study. So we're going to write the map and reduce into there. It's going to be something. The map is just going to be like, this maps to 1, the constant 1 function. I swear down. That's what it's going to be like. You mark me on my words. We'll find out in a sec. Fucking happened again every time I get a bit animated. Just a kind of, yeah, it's a really interesting kind of psychological thing. But I'm going to accept it, I'm not going to talk about it anymore, not dwell on it. You will also have to write the map and reduce the app. You should not need to modify any other files, but reading them might be useful in order to understand how the other methods fit into the overall architecture of the system. Emphasis on might. We'll see, I'll decide myself if that needs to be read or not. Let's tell you what we're going to do just to speed things up a bit. Skim read the rest of everything. So I'm going to just skim read this to see in general terms what we're going to do, and then I'll have a better idea of what MapReduce is going to be like to do as a task, as a lab. But before that, I'm going to do a 2-minute break just to resynchronize the stream. So we have the usual test. Pretty good, look, if you look at the iterated ones. I can see on the last one the hand is slightly faster. On the third one, sorry. The third one deep. This one. I can see the hand is slightly faster. No, it's back to normal. Because we're looking at when the mouse starts to move and when the hand starts to move. No, I'm happy with that. That is synchronized. I cannot test audio synchronization without recording and playing it back. I'm not sure if that's a thing that I should do. Maybe. I'll test it out later. For the time being, never mind. So yeah, okay, I think I'm going to call this a day after I read through all this shit. Very, very quickly, just in outline. Because then we have a kind of idea for what we're going to be doing starting tomorrow morning. Well, 12 PM is morning for as far as I'm concerned. So let's do that. A quick hardware test, 80 degrees. Toasty. Yes to the 80 degrees. If we hit 100 degrees, I might just start singing the Sampha song. Except like anthropomorphize the laptop. See if I can put on my like almost falsetto voice for that. I don't know. See how it goes. MapReduce implementation you are given is missing some pieces. Again, like I wish it were missing more, but it would probably take too long. Before you can write your first MapReduce function pair, you will need to fix the sequential implementation. In particular, the code we give you is missing 2 crucial pieces. Do you know what? I'm going to take notes. I think this is a decent idea, so I'm just going to write down in Notepad a brief outline of what is what. Let me just yeah, because the screen is kind of square, which doesn't help. But the notes are going to be minimal, therefore I'm going to put them up in this corner. So they're sort of above them. I think that's about right. If I hover above Streamlabs, can I see the No, because it re-renders fucking immediately. Look at that. Sorry about this if you're a bit triggered by things flashing. Is that right? I'm not going to be too much of a perfectionist, I promise. It's about right. Lightning strikes! Not once. Literally twice, but in a different place. It's just lightning everywhere. Shouts out to Sandinista. Still one of my favourite albums. Probably my favourite album that's I like more subjectively than objectively. Like the actual musical quality I kind of think isn't there as much as I like it. I just really dig the feel of that album. I get on really well with it, and it taught me, learned me what a good dub sounds like. So you gotta pay your respects to the Clash for that. Spreading the knowledge, spreading the toasting. To Mikey Dread. Sorry. The MapReduce implementation you are given is missing some pieces. So much lightning. Yeah, sequential implementation, in particular codes, source types. Sequential. The function that divides up the outputs of a map task, and the function that gathers all the inputs for a reduce task. These tasks are carried out by the doMap function in common map.go and the doReduce function. I'm hoping there are no name collisions between files, because that's fucked if there are. But no, it should be okay. These are the files that they are in, respectively. The comments in those files should point you in the right direction, of course. doMap. Oops. So much lightning. It's a shame I can't stream the lightning. I guess if I turn the camera around, can I do that? Let me think. If I, sorry again for procrastinating. Just for a minute. I want to see if I can get a bit of the screen inside. Just for the atmosphere, just for the vibe. Budge myself over. This fucking cube here is getting in the way slightly. With the way I'm sitting, I need to push the stand down a little bit. What if I could just zoom out slightly? There's nothing wrong with that. Okay, there was a flash now, but I don't think it was visible. Come on, it's just so black outside. Like flashes, and they're just not coming off on the camera. If we zoom in by looking at this. Yeah, I think it's a question of like contrast as well. Dynamic range of the camera. That the exposure is such that it's not going to be able to pick out like really low light on a dark background. But that's how it is. Okay. So what did we say? doMap. What that does is divides up outputs of map task. doReduce gathers inputs for a reduce task. Yeah, so each reduce task is preceded by a doReduce. Well, as in doReduce runs the reduce task, I'm pretty sure as well. it says it's missing the function, so I'm not sure if it's missing the whole function. Yeah, it is, isn't it? It's a huge amount of comments here. Hints on that. So I am just going to, yeah, fill those in, I guess. Wonder if I can get struck by lightning here. I'm not sure it's possible. So that would make the stream a bit more fun. Yeah. Lightning strikes. Point you in the right direction. Do map. Divides up the output of a map task and gathers the inputs. They're completely empty, so I feel like there are going to be things with workers and whatever. Don't know, we'll find out. I say that all the time, I should stop saying it. To help you determine if you have correctly implemented do map and do reduce, we have provided you with a Go. If you have correctly, we have provided you with a Go test suite that checks the correctness of your implementation. These tests are implemented in the file test. Why is it called test and not just test? Test just sounds a bit silly. If they'd called it check, I would totally be on board with that. But test is just what? Yeah, test for the sequential you have now fixed. What do you mean now fixed? I haven't fixed shit yet. Well, I'm supposed to be skim reading this. Run, okay, CD 6.824, which I have actually called DS. Export. Go needs go path to be set to the project's working directory. This is some initialization code to run in the shell. The shell being, well, basically like Windows. The program that, the operating system interface, what allows you to do stuff. So this isn't, this isn't program code, this is code for running the program from the command line. I think everyone knows what a command line is. Go needs go path to be set to the project's working directory. Do that to set it. Yeah, go test run sequential. Shall we run the failing test? Why not? Just to see quickly. It's not usually my style to like run. What are my other documents? Some bullshit. Oh, actually, yeah. If you have a Wii, copy the save files onto the SD card. Get a card reader. Dell XPS luckily has one, and just copy them in here, just to back it up in case it breaks. Like I did that on the 11th of May. Should have done it years ago. This Wii is almost 11 years old. And we have codes as well because everything is stored in some random format. So these are the Wii games that I've played. These are the ones that are copy protected, and the GameCube games are also missing. It's raining like shit. Lots of lightning now. Yeah, soup. Don't scroll back. Which game is soup? Never mind. So yeah, let's give this a shot. So to run the shell, I do git bash. Git bash is the Linux shell. Zoom in. Which is a bit nicer than the Windows shell. It's still pretty shit in my opinion. Like it doesn't treat spaces properly. It's really quite old, from the 70s, but not. Not as bad as, sorry, not as good as like C and that kind of stuff. Like it's just so many spaces and so much thunder, man. When I told my mum there'd be a thunderstorm, she didn't believe me. Now he's laughing. It's interesting that it says vote here. I don't know why. Vote with a 0. Yep, so this is our command line, the Linux shell, bash, git bash. I don't really know what the difference is between bash and git bash. It's just a implementation of bash for Windows, I guess. Git could be on Linux as well, but as in this runs on Windows. So what was I gonna do? Try to run the test code. Let's run this shit just off the cuff. Let's see what happens. Can't load package, no go files. No go files, good one. So therefore we are going to export the path. The DS folder is going to be the path. What they're calling 6.824, that's going to be the path. I fucking hate how I have to do control insert to paste, or is it shift insert? I think it's shift insert. No, it's control insert. Oh, for fuck's sake. Like pasting on bash is just click the mouse and it pasted. Okay, so now if I run go test, what happens? I think the same thing might happen that happened last time, because there are no go files. What we're going to do is, okay, we've set the go path to the working directory. Okay, now we're going to cd into cd stands for change directory. So as you can see now we are running in the DS file. If I run the change directory, we are now running in src MapReduce, the MapReduce folder. And go path is the fact that that's in CD, that means it works correctly. It sets it to the correct thing. So we've set go path correctly. Honestly, I don't know what go path is, why we care what it is in Node. I don't need to use that kind of shit. Oh yeah, I should also say, so this command which sets go path to whatever pwd is, pwd stands for print working directory. So if I run pwd, it will print the working directory, which is where we are. Okay, so now we should have everything in place to be able to run this. Go. Shift insert is paste. Okay. This should fail, and hopefully it's not going to wreck the CPU. It went up for a bit, but it's fine. Fail. Yep, we ran a fail with a cannot find the file specified. Best error. The file isn't even there, let alone correct. So yeah, all good. You receive full credit for this part if your software passes the sequential test. So this is what I mean. We can test ourselves, we don't need to submit to MIT. You know, as run by the command above, when we run the software on our machines, which is what, yeah, so you know that you've done it right before you send it off to MIT, which is, you know, I respect them for that. There's no guesswork, no randomness. It's not like fucking Tripos. Everything in Tripos. Tripos is the Cambridge, any Cambridge course is called Tripos. Is this wet? Yeah, I'm getting spittle from the rain. Oh, that's not good. Shouldn't sit so close with this computer, should I? It's gonna get humid. It's gonna get humid, but it's also gonna get cool. So, the fan is on low, which is good. Oh, I do wish I had, because I want the atmosphere, so I want to leave it open. But yeah, it's getting a bit humid. Really wet here, actually. I should probably not be using the computer here. Do you know what? This is what I'm gonna do. Put the camera back, put this shit source mouse away, microphone pointing away from the rain, and just sort of move into the corner. Jesus, why? This is wet now as well. I'm not even using the fucking paper. Okay, let me just get my bearings. So I'm gonna just slump into this corner while it's raining. Get the computer out of the way. Get the camera in the correct place, like that. You still cannot see the lightning. Sad times. Sad boys. Wah. This is uncomfortable as fuck. I can get into the... If I get into... Sorry, microphone contact. If I just get into the full corner like this, and hope the phone is vaguely protected. Yeah, this is fine. I like this. I can see the rain on the microphone. Exciting. Whoa, fuck, that's heavy rain. I'm not sure this plan is going to work. It's got even more wet now. So much rain. It's just the computer explodes or something like that. So I'm just going to keep the computer away from the monitor. I can do that. I just leave it here. God, it is raining like hell. I'm gonna just close the window slightly. I want to get a bit wet, but I don't want my computer to break. Achtung! Okay, I've moved the microphone in a bit closer as well. Where was I? Rain is, I think, good for motivation because it just makes everything that much more exciting. Turn the volume down slightly. Yeah, that's fine. This is definitely first time stream. I'm just paranoid about getting the, making the audio inaudible or something. But this is pretty good. I like this. Pretty convinced it's fine, and I have some rain in the background as well. Yep. So I ran the test. It failed. If the output did not show okay next to the result, your implementation has a bug in it, or I just didn't do it at all. To give more verbose, you can set debug enabled in common.go. No? Are they sure they mean common.go? Well no, as in you can put debug enabled equals true on top of the thing. Oh wait, sorry, I scrolled too far, here it is. Yeah, just set that to true to get verbose output. I'm just gonna set it to true anyway. This is the first edit I've made so far to this file. So if I save it, you will see it here. That Git is gonna be like, yeah, something updated. I can push it if I want, but I'm not going to. Trivial change. What have I done? Using Alt-Tab and the 3-button press on the Ultrabook at the same time. Yep, set debug enabled to true in common.go. I just did that. To add -v and add -v to the test command above. Okay, good to know. Go. The command is go test -run sequential. Whatever that means. Go runs go test. Don't know. Some sort of testing library. Do we think there's a testing library? Probably. Run does something. Does something. Sequential is the function that we are testing. Sorry, I'm just enjoying this so much. The rain is so loud now. A bit of white noise never hurt anyone, It's good for the soul. Yeah, okay, so I'm speaking a bit more loudly just to carry over the thing as well, over the rain. You will get much more output along the lines of yeah, actually, you know what, let's just do that now. I'm fucking about with this, but why not? I'm getting so wet. It's fucking hailing. Dear lord. Is that actually... No, it's just heavy rain, but everything's gonna break if I... Sorry guys. I wish. My smell of like pure water. It's great. Am I sure there's not a way that I can just get a bit more rain in here? Just that outdoors vibe. A little bit. My face is getting so wet. The microphone is getting wet as well. It's not good. I should I've had an idea. Okay, bear with me. This is like, what the fuck? But like my hand is now wet, so I can barely even use the laptop. Can we see the? Oh, you can't see it because it's just off screen. This is what I've done with the microphone. Just put it in the fucking bed, like, yeah. This box is completely wet as well. Yeah, I had to close the window slightly. Soz guys. Let me just get a bit more vibe in here. Okay, sorry. I'm getting so distracted by this rain. Live streaming rain is just like fascinating to me for some reason. So if I run standard go test, it should do the same thing it did last time. If I add the V flag, for fuck's sake, I print the screen by accident, now I have to copy it again. You can copy just by pressing enter, it's great. No you can't, because you need to be careful that you don't copy a line break. Let's go. Well, to be honest, cannot find the file specified is a pretty basic error, and no, you're not gonna get more information than the file does not fucking exist. Like, okay, cool, whatever, man. Oh shit, my tissues are wet. Yeah. Just Radiohead's Just song has just started playing in my head, like, you do it to yourself. Sunny weather's gonna be a vibe as well. When the actual sun comes out, it's gonna be a fucking vibe. Okay, let me try. I'm gonna end the stream pretty soon, like, it's getting a bit, it's so distracting. Okay, let's just, so that's the entirety of part 1, so like, I think I can bash this out tomorrow. In principle, sorry, not even tomorrow, next session, so like the next 2-hour session. This doesn't seem like it should be that hard because, I don't know, it looks short. Famous last words. That's part 1. Part 2 is the actual case study, single worker word count. Single worker meaning we're still keeping it as if it's sequential, kind of. It's not going to be completely because there's going to be a master and a worker and those are concurrent, but like it's easy to get to that from sequential code, and so if you can debug that slightly concurrent thing, it should, you know, put you on the path to doing the rest of it. Let me talk quickly. You will implement word count, a simple MapReduce example. It's in here. Find empty functions. Your job is to insert the code so that WC Go, so wet. WC Go reports the number of occurrences of each word in its inputs. Yeah, it counts words. Look at this fucking this clause, phrase even. Reports the number of occurrences of each word in its input, like, counts the fucking words. A word is any contiguous sequence of letters as determined by Unicode's letter. Gee, that's fucking helpful, isn't it? I'm gonna say a word is, alphabet A to Z, capitals and small case, and but not spaces. If there's a hyphen, I don't care. There are some input files with path names of the form pg-start in source main, downloaded from project Gutenberg. Impromptu accent. Gutenberg. No, it's not. Sorry, I pronounced that wrong. Gutenberg. 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 Here's how to run WC. Go run wc.go master. Yeah, so we're taking wc.go. This is the master. This is the routine in the master. The routine meaning the function. pg.thing is the file that we're inputting in the function. So those are the command line arguments. And this is the output in the example, missing return because you fucks up the implementation. Computation fails because they're not complete, i.e. return is missing. Cool, okay, I can believe that works. I'm not going to test everything out. As in, I can believe the command line shit works. The actual functions are obviously not complete. Review section 2, your mapf of the paper will differ a bit from those in the paper section 2.1. Mapf passed the name of the file as well as the file's contents. It should split the contents into words. Return a Go slice. Slices in Go are arrays. In an interpreted language, that is what a list is, not an array. An array is more a low-level concept. In Go you have arrays and slices, and the array is how the data is stored in memory, and the slice is a wrapper around the array that makes it easier to work within the actual programming language for the person doing the programming. So I'm not going to bother explaining the difference, what an array and a slice actually are. You can check that if you want. It's vaguely interesting, but I can't be bothered to talk about that. So while you can choose what to put in the words, these are just details. Your reduce f will be called once for each key. The keys are going to be the words. Does this give us a basic intuition on how the word count example works? It says you can choose what to put in the keys and values of mapf output. So mapf is supposed to be outputting keys and values, right? It's supposed to be outputting a dictionary. So this is what I mean about not having read the lectures. I'm probably going to Google that next session. So the keys are going to be the words. It only makes sense. It only makes sense. The keys are going to be words. And the values are going to be how many times each word comes up. So we increment the value by 1 each time. That's the kind of naive word count via a dictionary implementation. I'm not going to do one of those are less obvious. How would you program a word count, generally speaking? Traverse the string. So the string is like the whole... String literally just means text. So in this case, the string is the entire paragraph. I should probably dry off the lamp. It's looking a bit dodgy. Yeah, so what was I saying? Sorry, move the microphone. Yeah, so in this case, we traversed the string being the entire text that we're word counting, and we split it up. We pass it by reading one character at a time. At the point where we read a space or something that's not a letter, we take note of what word we found, and then we look into the word count dictionary. Pass the word that we have just found into it, and increment whatever that word is. So the word is the key. The key gets passed into the dictionary, which is the word counter. It's clear to me what all this means. I'm trying to explain it. And so the words. Sorry, okay, I'll slow it down. Word count is. Stores are, of course I could just be doing a visual demo. Word count stores, let's call it WC. Word count is a dictionary. That does not make sense in normal English language, but yeah, for our purposes, word count is dictionary. The word the appears 5 times. The word and appears 4 times. And so this is what the word count looks like. The keys are the words, the values are the numbers of times each word comes up. And so when we pass the string, we pass it left to right, reading each letter at a time, and when we decided we have a word, namely when we find something that's not a letter, we switch to the next word. We passed the word into the WC dictionary, which is to say, oh, I found the word word. This is the word that I just found in my text. Word. Word is the word. You know what? Fuck that. Bird is the word. Thunderbird is the word, and you're right, it's a feather. Bird. So we look at WC bird. This is a bit of a pseudocode. WC bird. We access that, and because bird isn't in WC at the moment, that gives us a value of 0. We run that, and the value we get at the end is 0, pretending. And so, because we have found the word bird, what we're not actually running, we're not just accessing it. What we are doing is incrementing it. So we're saying this equals itself plus 1. So equals is the assignment operator. This equals means that whatever was there is now WC bird again. Whatever was there. So this is whatever is there. Is now whatever was there plus 1. Fuck's sake. Plus 1. Okay. Nice thing about these kinds of programming languages is this can be written literally like this. So that's why C++ is called C++. It's like someone took C and added 1 to it. Right, and so the output is now 1. And the dictionary looks like this. Sorry. I can't even see the fucking cursor because I'm blind. But Boyd 1, like that. So this depends on the language. In Golang, the language we're using, if you increment a non-existent key, well, actually, yeah, dictionaries in Go are typed. So this isn't just a dictionary; it's a dictionary of integers. The values are integers, and the keys are strings. So you would write that in Go using the notation map, which is its word for dictionary. Dictionary and map, I think, means slightly different things, but this is not the same map as map in MapReduce. What's the notation in Go? It looks something like I can't actually remember the fucking notation, but it's something along the lines of map string int. Does it look like this? Or like that? I don't know. It does not matter. We'll find out when the time comes. But yeah, basically it does that. You get to the end of the text that you're word counting words, and you end up with the full array of words. And then you know how many times each word comes up. Word count, generally speaking, counts words without regard to what the word is. What I've described is not just the word count, it's a per word count. I think that's what the example actually is. So map, what would map do? I think map still maps every word to 1. Reduce runs for each word, it picks out all of the words that were mapped. They're not just mapped to 1, they're assigned to the reduce task corresponding to the words that was mapped to 1. I think. So it does that. And then reduce adds up all of the map tasks that went into that particular word. So reduce doesn't care what the word is, it runs each word individually. Map sends the word to the right place, but it actually maps it to 1 so that reduce can add it together. I'm bullshitting, you know that I'm bullshitting, but I'm just trying to get a feel for what we expect is going to happen. Yeah, we'll find out later. This is a standard example, so I can just Google it if I get stuck. Yeah, reduce f, yes, it literally says, right, reduce f will be called for each. So reduce f is the reduce pure function, the underlying reduce function that we're applying to everything, the same way map f is the underlying map function. We will be, reduce f will be called once for each key. each key being each word, with a slice, namely a list of all the values generated by mapf for that key. So maybe mapf is actually splitting the text up into paragraphs or something. Maybe it's not individual words. If it were individual words, everything maps to one. So yeah, it picks up everything that was generated by mapf for that key. It must return a string containing the total number of occurrences of the key. Oh, and then the final reduction probably concatenates all the strings. Concatenate means joins one after the other into a big string. Probably concatenates all of these, all of these for each key in one list. You can use this to split a string into components. That's probably the initial subdivision of the task. String conv is handy to convert strings to integers. Okay. Test your solution using so $$ is the commands that you input. So we set the directory to main folder, and then we run it with time, which times the code. Go run wc go master sequential pg whatever. 2.59 user. I don't know what that means, and this is the total time, I think. The output will be in the file that. Your implementation is correct if the following command produces the output shown here. This looks like a word count. Okay, this is it. Yeah, this is the final word count. So it's each reduce task sends out one of these lines, and I guess the final thing is to just put them all together, or not, or just return them as a stream of text. Who knows? Like, remove the output file and all intermediates with remove. Try not to run just like remove.star or something stupid. To make testing easy for you, run bash. Why is bash there? Don't know. .test wc, and it will report if your solution is correct or not. Looks good. Okay, I'm gonna really stop now, so I'm just gonna really skim the rest of it. Map and reduce tasks one at a time. One of MapReduce's biggest selling points, so this is what we were talking about, automatically parallelize, right? So automatically sends out ordinary sequential code without any extra work by the developer. So the point of MapReduce is we are simulating MapReduce, which is a real-world library used to process data in parallel like this. So this is, explaining that sequential code without any extra work by the developer. In this part of the lab, you will complete a version of MapReduce that splits the work over a set of worker threads that run in parallel, multiple cores, all computers, both, Okay, we'll be running on multiple cores on one computer for the purpose of this coursework. While not distributed across multiple machines, as in real MapReduce deployments, what I just said. Your implementation will use RPC to simulate that it's doing that. Checks out. So master does most of the work managing. We also supply you with the complete code for a worker thread, as well as some code for the RPC. Your job is to implement schedule. Yeah. Okay. Cool. This looks, it looks kind of trivial. I feel like it looks like they've removed all that was hard about this. But I still require a bunch of Googling for me to find out what do map and do reduce are supposed to do. Schedule learns about what workers are available via the register chan argument. That's a channel communicating between computers. Yields a string for each worker containing its RPC address. Remote procedure call. Some workers may exist before schedule is called, and some may start while schedule is running. Fine. They just they literally just drop through this channel. Use all the workers, including the ones that appear after it starts. That's fine. You just iterate over the channel, and run stuff on it. I don't know. Let's find out. Schedule tells the worker to execute a task by sending a worker do task RPC. Details. Blah blah blah. Call sends. I'm starting to glaze. Okay. Yeah, the submission C, it only checks one file, so you're not allowed to check the others. You can modify the other files as part of debugging, but then you need to fix them in order to make sure your code works in the normal environment, which is to say, you're not actually allowed to change some of the other files when it comes to the actual final answer. Yeah. Stuff, man. This is optional. Handling worker failures. I think I'll still do it. Seems like a useful thing to learn about before we move into Shard. Oh, is it not optional? The fuck? This one's optional. This used to be optional. I swear down, this used to be optional. I'm going to prove it. By going to the 2017 website, Lab 1. Nah, maybe not. Maybe 2016 is the one I'm looking for. I swear I once thought this was optional. But no, it's not. Oh dear. Okay, well I thought it was, to be fair, I thought it was pretty important. Didn't understand why it was optional in the first place. So, 2018. So, yeah, like, I will also do that. No problem. And what's the last thing? The last thing is optional. Index generation, which is something that makes... well, here, read this. Document searching, you know, it's indexing in general is just a way of making data easier to search. An inverted index is a map from interesting facts about the underlying data to the location. So, for example, it might be where the keywords are. Map, another word for dictionary, like I said. Associative array. And then, yeah, there is some other stuff. And, yeah, that's it, mate. And in procedure. Dawn of a new day. 72 hours remain, motherfucker. No, not really. To be fair, 72 hours is about the amount of time I'm willing to spend on MapReduce. If it goes over, fine, it went over. But I wanna see if I can knock it out by doing morning sesh, evening sesh, morning sesh, evening sesh. 5 times, this being the first. So because this was a ramble and I didn't end up doing much, and it took fucking ages as well. Just looking at how long I've been streaming, it's 2 hours 38. So you know, definitely gonna wanna finish things up. But as a general point, 4 maybe 5 2-hour or so sessions. If I have to read a lot of stuff, hopefully I will try to distribute that outside of the actual live stream. And in that time, I hope I can knock out MapReduce, the beginning. Then we move on to Raft, sharding and all this shit, learn about distributed systems. I'm actually, I'm looking forward to it. I mean, distributed systems is interesting to me, like to learn for its own sake, and that's why I'm live streaming it. I'm live streaming it also just to keep it a bit more interesting for myself, to keep up that motivation where I'm explaining everything, particularly when we get into the actual content. But like, lots of different topics in Chomsky, like for example basic algorithms, I don't find interesting. I just don't care about them that much. I'm almost into it enough to learn it for its own sake, almost. But I would like there to be a practical example. That's why I'm doing the practically oriented simulating an actual library that's used in the real world. I would much rather I could do a project where I could literally do it for real and learn that way. That's what I did with the Pokemon Go bots. That's how I learned Node, JavaScript, asynchronous stuff, literally all this stuff. But doing a real world distributed system is a bit just like this is a good compromise, I think. It's practical. Not a lot of that stuff I'm not implementing by myself, unfortunately, so there's going to be a bit of mystery. I might read some of the underlying codes. There's a lot of stuff here, like I'm not supposed to edit this. What the fuck is it doing? I do not know. But yeah, it's like, yeah, I'm like I said, that I have the live stream as well, so I have the schedule. I'm looking forward to it. Much more than I was when I was learning algorithms. That's for certain. Maybe I'll do algorithms this way as well, just for the motivation. But yeah, that's it for today. I don't know if there's anything that I should really summarize. I haven't done anything yet. If I'm doing a quick summary, I haven't done anything yet, other than set debug to on in this file, so I can. Oh, another thing, I have differences. I know what's changed. Look at that. I love Git. Integrated into VS Code. It's beautiful. But yeah, basically, that's the only thing I've done, which means I've not done anything yet. So, tomorrow it begins. We're going to focus on task 1, which is implementing the actual the basic framework of MapReduce, I guess, the function that divides the outputs up for of a map task, and the function that gathers it for a reduce task, like the crucial pieces. That's the only thing we're bothering with. Word count means implementing the map and reduce pure functions, the functions we're actually applying via our mapping and our reducing. This bit is trivial, I think. Honestly, I'm not sure what. I'm just implementing standard code here, I think. No idea. So maybe this will finish early. Yeah, the distribution means implementing the scheduler. So we actually have workers and shit. Even though a sad face, we are not implementing the actual workers, we're not implementing the master. But fuck it, doesn't matter. We're learning still. And yeah, handling worker failures, we'll see what that's about. So I guess that gets chucked into the scheduler as well. Yeah, see, solution to part 4 only involves modifications to scheduler. And that's that. Hopefully that will cover the next 4 days. We are doing MapReduce. After that, I'll take a break for a few days and come back to Raft. Sorry if I'm antagonizing anyone by saying that. Which is, it has 2 halves, it looks kind of long. What is it about? Fuck knows. Persistent state, dear lord. Yeah, stuff. But that's it, that's literally it for now, for today. I'm happy to end it there. Next stream, I see no reason to change the plan. It's almost midnight. The plan is, scheduling wise, next session is going to be midday tomorrow, so quite early. I'm jumping straight back on it. I hope I don't, if I feel like I'm doing too much work, I will slow it down, honestly. I am strictly casual. I'm strictly enjoying myself still, just doing the work at the same time because I like doing work. I'm just not going to overwork myself. But for the time being, because we just did a fuck ton of talking and not that much doing, there's going to be a lot of talking next time, but doing as well. So I'm going to continue with the plan, midday to 2 p.m. tomorrow. And after that, I might change my mind, but I think it's going to be 9 p.m. to 11 p.m. tomorrow as well, again. So it's going to be midday to 2, 9 to 11 every day until it's done, unless I decide to slow it down. Unless I decide I have to do a fuck ton of reading because I'm clearly out of my depth. Or unless I give up entirely because it's too hard. I don't think that's going to happen. Challenge accepted. The gauntlet has been thrown down, mate. Yeah, So that's it, and more details up on the Twitter, shout plenty, and on my Twitch page I'll just put in, and on this shit as well where it says sesh, next sesh. This one overran by an hour or so, a bit less. It's 2:45, so next session I'm just going to update, and that's how you'll know what's going on. And check it out, the rain's it's chilled out, it's a bit nicer now. Still have that lovely humid feeling in here. I like the smell of the rain, to be honest. And on that note, on that bombshell about the rain, I am out. See you later.